our social media platform will be closing shortly, like just about 10 minutes. So those who haven't yet used our hashtags, please do it as soon as possible, and don't forget to share about our community day today.
A post on LinkedIn or Twitter, we'll be tracking those posts and tweets. So please share it with your friends and try to bring more likes and retweets to your post.
So our upcoming speaker is Mr. Sanket Bisne. He is an expert in cloud computing and specialized in Google Cloud Platform GCP services.
He's working as a cloud engineer at Searce. He's a Google Cloud Champion Innovator. He's also certified in GCP Professional Cloud DevOps Engineer, Cloud Architect, Associate Cloud Engineer. So,
thereby, it is my great pleasure to welcome a renowned speaker, Mr. Sanket Bisne.
Please give a round of applause.
Hello guys, are you excited for this session? Okay, thank you. So, let's start. Myself, Sanket Bisne. I'm currently working at Searce, which is a Google Cloud Partner company. And I've been working for almost 2 years now, and in the specialty of cloud engineering department. So, as about bit about myself, I'm 3x certified in Google Cloud Platform. And also I'm a Google Cloud Champion Innovator from Google itself, and I've been writing blogs on several Google Cloud topics. I have created some blogs how to find the workarounds of different Google Cloud services which are not there on the internet itself. So you can follow me on Medium platform. You can follow me on LinkedIn. I'm also very active on LinkedIn, so you can connect with me. And yeah, fine. So yeah, I've already introduced myself. So before starting my session, I would like to know how many of you guys know the word Terraform. Just raise your hands. Oh, pretty much. Yeah, fine. So, okay. Yeah. So before starting the agenda, I don't have much beams, but definitely I will give you valuable content. So you will be remembering those words, and you can use this special words and special terminologies in your interviews itself. So let's you all be interviewing or anyone you are attending any sessions or related to Terraform. These keywords will help you to understand the Terraform, and majorly you will be gaining lots of expertise in this. So starting with the agenda, we will be starting with what is IAC, how it does work. Okay, what is the full form of IAC? Yes, everyone know I am there, aware of that. Introduction to HCL. What is HCL? It stands for HashiCorp Configuration Language. And then basically your architecture flow, how the Terraform architecture works generally. Then majorly we will be showing what Terraform workflow, how does it work, what are the basic principles of Terraform workflow, and then we will be creating our very first infrastructure through Terraform. I know that this demo will not be relevant for me, time permits. Let's see. Okay. Then we will be seeing modules in Terraform. What are the modules? Why we use modules? Whenever you create any resources in any cloud platform, let's say in AWS, in Azure, or any Google Cloud platform, you will interact with this word modules. And in any company you go, right? You will be interact with this word module, and your manager will say, hey, create this. This is a module of our company, and you have to create your Terraform code with the help of module. Okay. Then you will be seeing best practices in Terraform. Whenever in any company you go, you will be following these best practices so that any infrastructure you create, right, in your code, let's say anything. So basically you will be following these best practices. And then I'll be giving you a brief about your resources, and yeah, some Q and answers. If time permits, then we can connect offline at the end of the session. Okay. So let's start. So which IAC tools should you be used? So you can see on the slide there are pretty much tools. Has anyone heard of these tools or anyone have used these tools so far? Just raise your hands. Fine. Okay. So which tools you have used majorly? Just give a common bunk answer. Okay. Fine. Thank you. Majorly you will be focusing on Terraform in this case because the session is all around Terraform. So yeah, let's start. So as we can see, this is a cloud agnostic tool. What the word cloud agnostic word means, right? So it means that this Terraform tool can be used to create resources in your different cloud platform. Let's say you have to spin up a virtual machine. Has anyone heard about virtual machines here? Many, right? Okay, fine. Okay, so you can see the basically Terraform is used to create many resources in any of the cloud platform, not in GCP but in AWS or Azure. Okay. Then as you can see, what is it IAC means? IAC means infrastructure as a code. Okay. So I know many of have used the word code, right? All people are developers, right here? Yeah. So everyone has written some amount of code, let's say in JavaScript, Python or anything. So you write those code, let's say you have to create a program in Python, you write main.py, right, to create those programs. Let's say in JavaScript, console.output something, right? So basically you create a program which follows a sets of instruction to execute those tasks, right? So in the same way, we have an infrastructure as a code. So what infrastructure as a code means? We have a code in place that will create infrastructure. From morning onwards, you will be encountering such words just like cloud function, cloud run, BigQuery, Bigtable, and hell not, right? So basically, to create those resources, we don't go on console and click buttons, right? We have a Terraform code written over there, and just we have to apply 3 commands: Terraform init, Terraform apply, and Terraform apply. Those 3 commands will create your infrastructure for you. Okay. So what is IAC basically? It is again, Terraform is an open source tool which is used for your cloud agnostic tools. Just like you can create your resources in Google Cloud, Amazon or Azure, any of them, and not on cloud platform, but you can create your GitHub repository too. So I think everyone has heard about GitHub or any source repository you have used, right, in earlier, right, in your life. So you will be creating your GitHub repository by creating new repository icon on that website, right? So why? Basically, let's say I want to create thousands of repositories. So how I will be doing that? I will be not going into console and I will be creating 1,000 times new repository, right? So for that, basically, I will write a code. You don't have to be an expert to write a code, okay? There are again modules available onto their website. You go there, you just learn the syntax, how it works, and I will be giving you 3 commands in this session. Just apply those. Just clone this repository and just apply those. You will be able to just build your own infrastructure. Okay. So as you can see, Terraform can be used for AWS, then Azure, then your GCP. Okay. So basically, it is a cloud agnostic tool. It is used for creating, as Abhishek have already said, the multi-cloud setup, right? So basically, you can also set up your multi-cloud setup with the help of Terraform. Okay. So into the HCL. How many have heard about HCL? No one? Okay, it's few, right? HashiCorp configuration language. Okay. So write a Terraform code. We have a coding language. That is HashiCorp configuration language. Okay. HashiCorp has built this code, and we built this module on top of it, so that you just use it. You don't have to learn it or syntactically anything. Okay. You just copy paste those commands, and then you can go ahead with that. Okay. It is a language that Terraform uses to define your infrastructure resources. HCL is a human readable language that is easy to learn and code. Okay. So yeah, this was all about a 3-line definitions for Terraform. Okay. Then basically we will be seeing example to create 100 of virtual machine. I think everyone have heard virtual machine concept. Anyone have built virtual machine by just clicking on console itself, right? Anyone? So many, yeah. So basically this is a code to create a simple virtual machine. 100 virtual machine. Let's say I have to create 100 virtual machine, right? So this is the main.tf file. You just copy this main.tf file and you just execute onto that local machine. Okay. You will be able to see 100 of virtual machine get created, but the name will be unique. You can see the count.index right here. What it means that example instance 0 plus 1 means anyone has used for loop here? For loop, right? So for loop, what it does, it just loops around it, right? So count, what it takes basically, we have count 100, so it will just create 100 virtual machines on top of it. Okay. Then basically the hierarchy of files. So basically this was a main.tf that only create 100 virtual machine, right? But we have written the code. We have just hard coded these things, right? This is not a best practice. I will show you the best practice how it does in the session. Okay. So basically, hierarchy of files follow these methods generally. You have your backend.tf, you have providers.tf, you have main.tf, and you have output and terraform.tfrs. Okay. So in backend.tf, your backend initialized. Let's say you are creating a Google Cloud something, right? So your Google Cloud source will be defined in this backend. Okay. So basically, your Terraform do have a state file associated with it. Okay. So basically, whenever you create any state file, this state file is stored into your backend.tf file. Okay. Then providers.tf file. As I've already talked about the AWS, Azure, and GCP, where this information will be stored. It will be stored in the providers.tf. Okay. So basically, then again, you have an backend.tf, which defines the backend that is used for Terraform configuration. Then providers.tf, in which your AWS, Azure, and Google Cloud Platform information will be stored here. Then basically you have main.tf, in which your whole boilerplate code, that the resource you are creating, it will be defined here. Okay. Then you will be having variables.tf. Just like any programming language, you create a variable. Here also we create a variables, and we define all the variables in the variables.tf file. Instead of defining all the resources in main.tf file, we create separate files for manage these resources. Okay. Then we have output.tf. I want to see how much resources it has created, right? Which resource, what is the name of that resource, right? So in the output.tf, we define those resources that we have to create. Okay. Yeah. So this was all about the hierarchy and the versions. So basically in versions, let's say I have to upgrade the versions from, let's say, 1.3.2 to 1.3.4. All the versions configuration will be defined here. Okay. So the architectural flow, as we already saw, that we have main.tf, we have terraform.tfrs file, we have output.tf, many files, right? So basically you are a developer, you are a practitioner, you will be having your code written. You have to fire 3 commands: terraform init, terraform ply, and terraform apply. Okay. Then you will be able to see, you will be able to just spin up the resources. Okay. Terraform workflow, there are 4 workflow. Okay. Terraform init, terraform plan, and terraform apply. And another one, terraform destroy. I'll be showing you terraform destroy resources that will be seen at the end of the session. There are 4 configuration. To run any terraform code, we have 4 commands. Terraform init, which initialize your repository, which plan, and then apply. Okay. This -- auto approve flag is very dangerous, because let's say you have fired this auto approve command, then you will be it don't ask for the prompt. Let's say if you want to create 100 of resources, you have to click yes or no. So to avoid that, we use auto approve flag, but again it is very risky. Don't do that. Okay. So yeah. So creating our first infrastructure by Terraform, we have to authenticate this Terraform with Google Cloud. Okay. So to authenticate, we can use our user account. Let's say sanketbisne@gmail.com, and let's say you have created a service account. You can also annotate that service account, and you can just create your resources. Okay. Then deciding which resource to create. After authentication, we have to define which are the resources. Let's say compute engine, let's say IAM role, let's say buckets, cloud function, cloud run, anything, right? We have to define which are the resources that should be created. Then you can use Google official models, that is used to, you have an entire boiler code available with you, and just you can define the root and child module. Okay. Then basically modules in Terraform, you have a child module which have this backend, main, providers, readme, terraform.tfrs, and variable versions.tf, and we have root module in place. It does have 4 things: main.tf, output.tf, variables.tfr, and versions.tf. Is equals to what? This much. Okay. So we have this hierarchy that we follow. Okay. So there are again init, plan, and apply. Basically, you will be able to just remember the words by this meme: init, plan, and apply, and destroy. Okay. So yeah, the best practices in Terraform I've already shown you. Let's say you have to create many machines or anything, right? You can use modules. Again, you can use loops, for loops, counter. Okay. Then we can maintain separate environment. In production, in dev, in stage. Let's say we have 3 environments. Okay. You can just copy paste whole code into different folders, or you can achieve with the help of modules. Okay. So don't do this. This is very dangerous. Terraform destroy auto approve. If you fire this command, again, all the resources without any prompt, it will be just powered up. Okay. So this is the, you can just, if you have any questions related to anything, you can just ask me, and you can just, I will be skipping demo as of now. Yeah. These are the resources that I have already provided here. You can just take that resources, and this is the QR code you can scan, so that you can easily catch up the slides as well. So yeah, thank you.
Thank you, sir, for your exceptional talk and your undoubtedly influence on our future endeavors.
Now I'd like to invite Antrik sir to please felicitate our speaker.